Hi guys, in this video we will solve some practice problems in quadratic equations. So let's start with problem number one first. So problem says that the number of real solutions of this equation x square minus 3 mod x plus 2 equals to 0 is. So we need to find the solutions of this equation. The problem here in this question is that how to deal with mod x. Now, mod x, what kind of function is mod x? So, mod x is a operator that is mod. This bar is called a mod. There's a variable inside, which is the variable x here. Now, this is called a mod function. The property of this function is that when you say mod of some number, say minus 2, the mod function always says you I'll give back your number but with a positive sign. It will always be positive, so it will say 2. When you'll give it mod 2, it will take it as 2 itself. You give as mod 0, 0 is neither positive nor negative, so it gives back 0 itself. Now for your quadratic equation, let's rewrite the equation once again here. X square minus 3 mod x plus 2 equals to 0. Now mod x, how to solve this? Now as an answer, x can be 0 or x can be greater than 0 or x can be less than 0. There are only three possibilities. Yeah. Now if x equals to 0 and x greater than 0, the mod function returns the x itself. That is, if you pass a positive or a zero number inside a mod function, it gives you the number itself, as we have seen over here. Yeah. And when you give a negative number, say mod of minus 2, it gave you positive number. How can you represent that in an alternate manner? Minus of minus 2. So basically your original number with a negative sign. So your original number is x with a negative sign. This is for when x is less than 0. Okay. So we'll solve it in two parts. Part 1, x greater than or equals to 0. So your equation will look like minus 3 mod x will remain as x itself plus 2 equals to 0. Here you will factorize the equation. Minus x plus 2 equals to 0. This will be factorized as x minus 2, x minus 1 equals to 0. So x can either be 1 or x can be either be 2 if we solve in this manner. Now the primary assumption here was that x must be greater than equals to 0. Is x following that condition? Yes. Is it following? Yes. So these both are a valid solution. So we have got a solution 1, then we have got a solution 2. Now let's see if the when x is less than 0, uh, do we find a solution? If yes, what will be the solution? So x square minus 3 mod x plus 2 equals to 0 becomes x square minus 3. Now mod x will become minus x, as we have discussed when x less than 0. Yeah. So minus x plus 2 equals to 0, which becomes x square plus 3x plus 2 equals to 0. Factorizing it will give the following factors: x plus 1, x plus 2 equals to 0. So x can be either minus 1 or minus 2. Okay. Now, is this following the assumption that x is less than 0? Yeah, it is. This as well. So these are another set of solutions. So solution number 3, solution number 4. So to satisfy x square minus 3 mod x plus 2 equals to 0, we can have 4 set of values for the variable x. What are they? X equals to minus 1, x equals to minus 2, x equals to 1, and x equals to 2. So hence solve. We have solved this problem, and this was an interesting problem where you would use the properties of mod x function. Let me give you some more idea about mod x function as a thought for brain. Basically, mod x function, as we have said, right? If you assume x and y, okay, and someone is saying y equals to mod x, what do they mean is that you take a number x, I'll put a mod function to that, whatever the mod function gives, I'll assign that value to y. So if I take x as 0, mod function will say okay 0, then it's 0, so y equals to 0. Okay, what about x equals to 1? If x equals to 1, then mod will give 1 itself, positive number goes inside mod, gives up the same number, so becomes 1. So 1, similarly 2, similarly 3, so it will become a straight line, yeah, going until infinity. And when your number gets negative, so it gives, say you put a negative number, negative 1, so it gives you positive 1 itself again by making that number positive. You put minus 2, it gives you plus 2, yeah. So it looks like a V shape. I'll redraw because this has been drawn by dotted lines, may cause some confusion. So this, both lines are your function, y equals to mod x. So this is an interesting one, and as you can see it looks like a V shape. It is minimum or 0 at x equals to 0 and then rises on whenever you go on any side of x, that is you raise x or you let x fall. And it's not a curvy thing, apart from my poor drawing, it's a linear one, so it's a straight line both sides, and it goes to infinity at both ends, yeah. So hope this will help, and do tell me in the comments that what do you feel about this function, and any questions you have about any problem about the mod function or about other questions maybe if you have in mind, yeah. Now let's move on to problem 2. Problem 2 says that okay, there is some variable alpha and there's a variable beta, and there is a equation which both follows, which is alpha square equals to 5 alpha minus 3, yeah, beta square equals to 5 beta minus 3. Then the equation whose roots are alpha by beta and beta by alpha is. So first of all, doesn't this equation seems to you the same? I mean, just you replace the alpha by beta and both are same. So replace alpha by beta and both are same, yeah. So can I represent it like this? X square equals to 5x minus 3, and x I'll take a value as alpha and beta. X, I permit the value of x to only be alpha and beta because I just want to mimic these above two equations, right? Makes sense. In other ways I can write x square minus 5x plus 3 equals to 0, and I put the values of alpha and beta, yeah. So doesn't this seems like only alpha and beta are the values which can make this expression x square minus 5x plus 3 as 0? Yeah. So this is a expression. You put a number x equals to 1. So this will become 1 square minus 5 times 1 plus 3, which is 1 minus 5 plus 3 equals to minus 1. So every number won't give you the number 0. Only the roots of the quadratic equation will give you 0. That is alpha and beta here. So from this equation, you can know that alpha plus beta equals to minus b by a. So what is b? Minus of minus 5 upon 1 equals to 5, and alpha beta equals to 3 upon 1. You can for the sum of roots and the product of roots, root 1 root 2 their sum, root 1 root 2 their product. The how am I arising at the numbers is by comparing it to ax square plus bx plus c equals to 0, and we know that sum of roots is minus b upon a and product of roots is c upon a. Yeah, so you now know that your sum of roots is 5, and you know that your product of roots is 3. Now someone is asking you that whose equation roots will be alpha upon beta and beta upon alpha. So assume that there is a equation ax square plus bx plus c equals to 0, and someone is saying its roots are alpha upon beta and beta upon alpha. Okay, so how can we solve this? So first of all, uh, assume that from this equation you find alpha and beta. So you have two known factors, but in this equation you need to find three unknown factors, a, b, and c. So to make this equation a generic one, I'll divide by a everywhere. So x square plus b by ax plus c by a equals to 0 becomes my equation. I'll say x square plus I'll say b by a, it's a number itself, right? So you can say bx plus c equals to 0. You call it any number, your equation might look like this, no worries. Yeah, so alpha upon beta is one root, beta upon alpha is another root. Now alpha upon beta plus beta upon alpha from this equation is minus b upon 1. Now alpha upon beta times beta upon alpha is c upon 1. Now this number gives you c as 1. Okay, so c goes to 1. Yeah, now the only thing which remains is this number to calculate b. Yeah, how am I going to do that? Alpha upon beta plus beta upon alpha equals to minus b. I'll take the LCM, alpha square plus beta square upon alpha beta equals to minus b. Now alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta upon alpha beta equals to minus b. Now from the above equation alpha plus beta equals to 5. I'll write it here as well. Alpha plus beta equals to 5, alpha beta equals to 3. So I'll use those values. So 5 square minus 2 times 3 upon 3 equals to minus b. 25 minus 6 upon 3 equals to minus b. So b becomes minus 19 by 3. Henceforth, your equation becomes x square minus 19 by 3 x plus 1 equals to 0. Yeah. Now you might say to me, okay, there is one assumption which you made. You divided by a. What if there is an a? So I'll tell you what really happens. See, let's say this is a equation which is our answer. Yeah, I am saying that there is not one answer. There are infinitely many answers. I'll tell you how. This equation satisfies your problem, right? Now tell me, will this equation satisfy? Yeah, it will. It's just that I multiply 3 on both sides. Yeah, 3 times 0 is 0. Now tell me, will this equation satisfy? It will. You multiplied it by 2 on both sides. So the equation remains the same, which means you multiply the equation with any number on both sides, and the right hand side will always be 0 because 0 times some number is always 0. And this side you get a equation. So there's not a unique answer, but at least we arise at a formula that okay, some number k times x square minus 19 x by 3 plus 1 equals to 0 will satisfy the equation. So you can say this is a generic solution. Just to give you a fun fact at the end, because knowing quadratic equation is fun and you should know stuff. So quadratic equation, how will this look like? Assume that we are only talking about x square minus 19x plus 3 and 19x by 3 plus 1 equals to 0. So since I'll just write the equation here, 19x by 3 plus 1 equals to 0. Now the graph of quadratic equations depends on the coefficient of variable x square, which is nothing here, so 1. Yeah, so 1 meaning it's going upward. Now this equation has a discriminant as 19 by 3 whole square minus 4ac 1 1. Now 19 by 3 is 6 point something something whose square is greater than 4, so this number will be greater than 0. So discriminant is greater than 0, which means this equation will have two roots. Now alpha plus beta, that the let's say the roots of this equation are x1 and x2. So x1 plus x2 equals to 19 by 3. Okay, x1 x2 equals to 1. Now product of roots is 1, so either both numbers are negative or both numbers are positive. Now since sum of roots is positive, so both number cannot be negative. This is wrong, both number has to be positive. So there are two numbers which are the root of the equation, and the minima should be somewhere in the middle, and the quadratic equation goes to infinity on both sides. When x equals to 0, your equation answer will, this term will become 0, this term will become 0, so your answer will be 1, so this number will be 1. Yeah. Now where will the minima occur? Minima will occur at minus b by 2a. X minima equals to minus b upon 2a equals to minus of minus 19 by 3 divided by 2 equals to 19 by 6, which is around 3.16. Yeah, you can expand more 1 6, so it's 3.16 bar actually. Yeah, so fun fact about this, yeah, you get to explore the function as well. Nothing bad about that. You get to learn more maths, and it will be helpful to you to understand what physically is happening. Yeah. So thank you very much for staying so long with me, and I'll keep bringing practice problems on several mathematical topics, starting with quadratic equations, linear algebra, geometry, circles, triangles, calculus, single variable, multivariable, differentiation, integration, differential equations, starting from elementary maths to advanced maths. Yeah. So do follow my channel. Please like this video if you find the content useful, and also write in the comments if you uh, want me to solve some questions, or you want me to teach basics of some topic, or try exploring some function, some problem for you. Yeah, thank you.